right now. All right, so we're going to walk through 3 of them today. We're going to look at the offset. We're going to look at the 90. We're going to look at a 90 with an offset. And we're going to look at, hey, where are you? Back-to-back 90. Let me reposition that. Don't like that it skipped. There we go. So 90 with the offset and back-to-back 90. We'll see how far we can get. All right, it's 7:40, so if we can only get through 2 of them, that's where we'll stop, and then we'll continue tomorrow. We will then continue tomorrow with combination bends to include the 90 with the saddle, which I've already got a couple things here, and the 90 with the 4-point saddle. So we'll get to those. The reason why I'm doing the offset, the 90, 90 with an offset, and back-to-back 90s is because these are the most popular bends that you will make. Very likely that you will make mostly 90s and offsets, and if you ever have to combine, it's usually a 90 with an offset and a back-to-back 90 that are used the most. So let's jump into it now. All right, so I'm going to set up a starting point and a destination where this is going to land. This could be anything, okay? We're just going to walk through an offset. So what I like to just do is, just to give myself something, is I'll put a junction box here, and I will put another junction box down here. All right, so this is our starting point. Let me try to make them sort of the same size. There we go, and there we go. Now we're going to make an offset, but as I said, you can also make a 90 to this. There are other ways to go into and out of a box. All right, so sometimes you have to make an offset, sometimes you have to make a 90. Now, this isn't a class about the offset, but I'm going to walk you guys through it a little bit because it's probably been a little while since you've made an offset. You guys worked with different conduits in C and B. So the first thing that you want to think about when you're going to make an offset is, where am I going in and where am I going to land on the other side? Because you're looking at a junction box, and I'm only going to 3D this now, or give it some dimension, you will have 1, 2, and 3 knockouts on the side of your box. So that's the first thing you want to do when you're going to make any bend, not just offsets, any bend. The first thing you want to do is pick where I'm going, because it's just a different measurement if I pick the top knockout over here and I pick the bottom knockout over here. That would be a completely different height than if I pick the bottom one here and the top one over here. This is a different height. So that's the first thing you want to do. The other thing you kind of want to do is you want the least amount of offset that I have to make. Why? Because I want to use 30 degrees. Right? That's everyone's favorite offset degree, is 30, because there's a lot of easy math around 30. It's the height or the rise times 2. That's an easy one to multiply in your head. If you use 45, then it's a rise times 1.4. You're going to have to pull out a calculator. I mean, you just have to, unless you can do that math in your head. So whenever we can avoid those decimals, and every other one has it. 22 is 2.6, 45 is 1.4, and 60 degrees is 1.2. So you have to include these decimals. The only one that isn't is 30. So that's one of the reasons. Whenever you have to make too big of an offset and you have space between these 2 junction boxes, I'm going to get rid of the 3D now, or the 2D. You have to also consider the space between these 2 junction boxes, meaning that if I leave here and I start to make my offset at 30 degrees, well, I might not be able to make it. Or I might only be able to do that if I use the bottom one and I go into the top one. So you always want to make sure that you are doing the smallest offset that you can possibly make. All right, just something. As we also, by the way, this will be the last conversation you'll have on bending. You guys will be moving into motors and, well, we'll be moving into other topics, and you'll be moving into motor and PLC. No conduit talks there. So I also want to make sure I'm wrapping up a lot of things that I want to make sure that you guys know about conduit bending. So if, in fact, going between here and here, I can't do 30, then I'm going to have to do 45. I might even have to do 60 if these junction boxes get any closer, right? So all of these are going to be factors that we're going to need to deal with when we're making an offset. So let's just pick the bottom one. We're going into here and here, and then we're going to make this offset going into here, and we'll go into the top. We'll call that the top of the junction box. Okay. Now, the two most important things about an offset is the rise of this offset. And for rise, to remind you, because some of the conduits are different, for example, a 90 is from the back of the 90 to the back of the other 90 if we're talking about a back-to-back. Or if this was a 90 this way, it would be from the back of the 90, that being the front, to the junction box. So for an offset, it's different. For an offset, it's from the bottom of the offset to the bottom of that side. All right, so bottom to bottom. Or you can say bottom to the back of the conduit. That's fine as well. So let's just use that one, bottom to the back of the conduit. This will be our rise. So that's going to be important for us for our cut length. The other thing that's going to be important is what degree did I use? So just for the beginning here, we're going to go with 30 degrees. Now, I'm going to go ahead and post the conduit bending formula that I think you guys have already gotten in the past. I know we have one down in our lab. And our conduit bending formula is also in your Uglies book, so this should have been with you in a few different places, but now I'm posting it there. So if you wanted to print it out or write it out, it's all good. You don't have to worry about the EMT stuff. We're only going to be looking at RMC. All right, which, by the way, if you do use your Uglies book for this, the Uglies book does not give you the RMC, but if you notice, it does because it gives you the EMT. So a 3/4 inch EMT has the same take up and the same gain as a 1/2 inch RMC. So the easiest way to know what the RMC number is going to be is look at the next size higher of the EMT one. So the Uglies book, just to save space, they don't give us the RMC numbers, but because they give us the EMT numbers, then we automatically get the RMC numbers. 3/4 RMC, the same as 1 inch EMT, and 1 inch RMC, the same as 1.25 inch EMT. So just to point that out. So this is the conduit bending formula. However, that is not, we're not doing 90s yet. We'll do them next. This is the offset bending formula here. And we're going to need to know 3 things. We're going to need to know the degree that we're going to be using. Actually 2, because we're not going to get into this. Like I said, this isn't about bending the offset. That is distance between bend that you would have to worry about. Just to give you a brief reminder of what that was, this is when you're going to bend the 2 offsets. The distance between the bend is, if we call this A and we call this B, this is what you get B when you do the distance between bend. All right, if I have my straight piece of conduit and I'm going to make an offset on it, I'm going to make mark A generally 2 to 3 inches from the front, and then B is the distance between the bend. All right, you make your first bend A, which takes your conduit forward. You turn the conduit over. Now A is facing the opposite direction, and now you bend B, and when you're done, straighten it all out, it looks like this offset that I have here. So remember, you're going to make 2 bends for an offset. And again, it's kind of hard to do in class if we're not in a lab making these bends, but just a reminder. Actually, let me do it this way so I can get rid of everything. If I do the reverse, erase, erase. Get rid of A, get rid of B. There we go. But we are going to need, I said, 2 things. We're going to need to know the degree, and we're going to need to know the shrink. Because this is the important part about the cut length, is we've got to calculate for, in this case, how much conduit we're going to lose when we make an offset, when we get up to the 90s, we got to figure out how much conduit do we gain when we make a 90. So we have to subtract the gain, but we have to add what we're going to shrink to the system. I'll give you the steps 1, 2, and 3 here in a second. So now that we know what degree, 30, so for shrink, I'll put it here. All right? You could memorize this one, not too hard. It's going to be R times a quarter, which I like to just use the decimal system. All right? It makes it very easy to do the math around this. All right? You can use your calculator. It makes it a lot easier to just use your calculator system. You don't have to turn things into a fraction. And we'll talk about going back to the fractions afterwards. So for the beginning here and throughout this whole real first week that we're doing this stuff, because you're going to get a couple things around this, a homework assignment and things like that, let's use the decimal system. Now, if you don't remember how to turn a fraction into a decimal, it's very easy. For example, if you have 3/16 and you want to turn that into a decimal, you hit 3 on your calculator, you hit divide, and you hit 16 and equal, and you get the decimal version of it, 0.1875. All right, this is the decimal version of it. Now, because we're going to be converting this back to fractions, but more specifically, we're going to be converting it back to fractions on a tape measure, right? We're not just converting this back to fractions where we can use 1/32 or 1/16 or 1/28. We're using a tape measure. So we only need 2 decimals, or 2 numbers after the decimals. So the other thing that I will do is instead of 0.1875, I'll simply make that 19. All right, so keep that in mind as I'm going to be doing that as we get into some of these math problems, which we will have decimals. So just erasing that. So now we need the next important factor, which is what's the length between these 2 points have to be? Or gonna be, rather, I should say. So that's the other thing we're gonna need. So I'm gonna give this some numbers right now. All right, the height, the length between these 2 spaces is gonna be, let's say, 36 inches. All right, arbitrary, doesn't matter what that is, but just for the question. So we have 36, from the junction box to the other junction box, or from a panel to a junction box, or from whatever to whatever. So now we have all the things that we need to come up with our total cut length. In other words, how long will this conduit need to be so that when I cut it and I thread it and then I bend it, everything lines up exactly like this. Because like I said, with EMT it doesn't matter. You just make the offset, let this be as long as it wants to be, and just cut it right at the junction box. All right, we got the connectors and we're done. But with this, we have to thread it, so we have to consider everything that's going to happen to the conduit. So step 1 of this formula, I guess we can call it a formula, is add all sides. Now, with this offset, and I'm going to get rid of this just to not confuse up here. With this offset, we only have one side to deal with. I'll put the shrink over here. Right? We don't have multiple sides to this. We only have the one length that we're dealing with. So we have all sides already, 36. I'll walk you through the first one. Then I'll give you one of practice. If we all do well, then we'll move on to the next one. Step 2. Plus 1 inch for threads. Because this is RMC and because you are going to thread this, you have to remember a very important factor, which is you want the threads to be inside the junction box. If you don't account for this and you just go with the 36 inches, then you'll cut, you'll thread, but your threads will end up on the outside of the box, and this is no good, right? You want the threads to be inside. Now, we do not need this thread to be massive inside, because what if a device is going to go into this junction box? What if it's a GFCI? Those things are gigantic. So I need space inside that junction box. So I actually want to keep that thread, while I do one thread inside the junction box, I want it to be as small as possible. So we're just going to give it a 1/2 inch on each side. All right, 1/2 inch over here and a 1/2 inch over here. And therefore, we just call that 1 inch for our total calculation here, for our calculation. So 1 inch. And now the last step is add the shrink. And the shrink is determined by this formula. So I have to give you a rise. So let's come up with a number here. Nothing major. Let's go with 12 inches. And so we'll multiply 12 times 0.25. Or if you want to do this with quarters, you know, it's $3 because 4 quarters per dollar. 12 quarters is $3. But you can just do math, 12 times, right? And now because you are using your calculator, 0.25 is easy. Now, yes, you could also do 12 quarters, 12 times a quarter, like 1/4. But the easiest way, I would say, just to use your calculator, 12 times 0.25, and you get 3. Also easy with 30 because it's quarters, right? So if you had 8 inches, well, that's 8 quarters. So then you have $2. So 12 times 0.25 becomes 3 inches. So now we just bring the 3 over here. And that is it. It doesn't get any more complicated than that. 36 plus 1, 37, right? Plus 3, 40. That is the total cut length of our conduit. Straight piece of conduit, thread half on one side, thread half on the other side, and now you can take it to a bender, if you're using a machine bender, or whatever the case may be, and make your offset. You can start this A wherever you want, usually, again, like I said, 2 to 3 inches from the front. Come up with your distance between the bend, which needs to be 12 times 2, 24. This 36 is going to be kind of tight, but not too bad. And then you'll set this up, and 1/2 inch thread will go in here, and 1/2 inch thread will go on this side. You might have to take the junction box off and put it back on. But you're good. I will add this one last part within a small margin of error. All right, there is a margin of error here, and always in conduit bending. Nobody is perfect. All right, just know that. Now, yes, I can cut this pipe perfectly to 40 inches, and I can thread it, but bending on a hand bender, there is a margin of error. Machine bender, Chicago bender, all the machines, and I'll put some videos up for my online students who didn't get to see those. There is a margin of error. Don't worry about, again, we're wrapping things up on conduit bending, so I want to give you some extra information because this will be it for it. Don't worry about if you didn't hit 12. If you did a little bit more than 12, a little bit less than 12. That margin of error is there always. The only thing you have to do when you're conduit bending, the most important thing, and it's something that I don't think teachers drive the point enough to students, is learning how to find the proper measurement. That is the hardest part. How do I know that this is 12 inches? There wasn't a conduit there. There was nothing there. I just had 2 junction boxes on a wall. So how good was I at getting that perfect measurement? If I'm good at that, then the mechanics of making a bend will just come with the hours that you put into bending. All right, which, by the way, again, as you wrap up conduit bending, if it is something you're going to want to focus on, my suggestion would be buy a bender. All right, a 1/2 inch bender. You can go to a flea market. You can go on Facebook Marketplace. Don't get a new one. Get one for like $10 that somebody's selling. And you can buy 1 or 2 sticks of conduit, 1/2 inch at Home Depot, EMT. Costs you $20. And for $30, you can practice again. And whenever you have another extra $20, you can go get some more conduit. You know, I get it, it's money, and money is always tight, but if you can, at some point, this would be my suggestion. And practice this stuff. Also, the other thing I suggest to you guys, especially, again, my in-person students, unfortunately for this one, is take pictures of what you're doing. All right? I would hire somebody if I saw their work on a portfolio. They're students, so where would they have gotten experience? Well, I'm looking at it. By the way, online students, you can do this from home. Set up a wall, piece of plywood, make some bends, takes pictures, show the future employer, say, this is what I can do. Nobody's giving me the opportunity yet, but this is what I can do. But it starts here. Again, measurements, big time, and then knowing how to do these formulas. All right, I'm going to put a sample one here, and then following this, I'll erase all that. Following this, you guys will come up with the numbers, and if we're all good, then we'll move on to the next one. All right, I'm just going to put 2 junction boxes, nothing in particular. Let's design this so it doesn't look bad. Here we go, and there we go. Change size. Starts as 1/2 inch, ends in the middle as 3/4, and then comes back to 1/2 inch. All right, so we want the height. Let's put a number here. Let's go with 8. We want the point to point of where we're going into. Let's just make this another number for another number's sake, 42. And then we want the degree that we're using. So now I'll give us a little bit of a harder one, not too bad. I will put the shrink here. Remember, oh, and I haven't told you this, but for the exams, you're allowed to bring your notes, something that we'll get, I'll just remind you of next Wednesday. This is one of the notes that you could bring. So when you get a chance, print this out, or you can write this out. And if you are going to write it out, you only have to worry about 30 and 45. I don't really ask anything about anything else. So for 45, here's our shrink formula, which again, I'll put it over here. R times 3/8, right? So if you want to find 3/8, which I'll simply just put here, 3/8, you can just do 3 divide 8 equals, and you'll get don't forget the decimal, 375, which you can just make 0.38. Okay, if you use 0.375, no big deal. With these, again, because there's this little margin of error, it doesn't matter if you're 1/8 of an inch this way or 1/8 of an inch that way. We'll talk more about that as we wrap up today. All right, take a minute or two, and all I'm looking for is the TLC, or TCL, total cut length, is what I'm looking for. How long does this conduit have to be? Don't forget the +1. By the way, as soon as somebody has the number, just let's say it out loud. Maybe we have 2 different numbers and we get to battle it out. See who's right. $46. All right, we'll put 46 over here, going once, going twice.
I'm also got 46.
As well, Roman. All right, so we got 2 that confirmed the 46. So is anybody else holding on to a different number? All right, let's walk through it. I don't think I see anybody else writing it out. Unless there's somebody off camera, but go ahead. So I'll just start slowly. So first thing we want is we want to adjust we don't have all sides with this one, we just have one side, so we only have to worry about one number, 42 plus 1, and then add the shrink. So if you use the 0.38, which is what I use, if you did 0.375, I'll explain that once we get to the end of this. And now we are going to multiply that by 8. If you use the 3/8, all same as well. 8 times 0.38 equals, and that's going to be 3.3 3.04. Actually, I should have put this right here. 3.04. So this becomes 4, right? 2, 3. So we have 6. We can ignore this 0.04. And so we will call that 46. So I will be satisfied with 46. If you use the decimal, you have 0.04. So if you wrote, for example, on a homework assignment, one person has 46 and the other person has 0.04, both of those would be correct. Because again, with conduit bending, there is these little margins of error, not error in some cases, just like a 1/16 of an inch or an 1/8 of an inch that really is not going to affect anything. All right, before we go, just to put it out there, does anybody want to do this one more time?
Just can you show me the table of the measurement?
Yes, absolutely. And it is posted already online, so you guys do have access to it already.
Okay, got it. And plus EMT2, please.
Yes, absolutely. Take up RMC, yep.
Thank you.
You're welcome. All right, so the take up is what you need when you're going to make the 90. The gain is what you need for the cut length. So if we don't have any follow-up questions on this one, and you know, usually we only do 2. Sometimes we get to a 3rd one. It's just these take a minute to explain everything. Let's get to the next one, which is a 90. All right. So none of the precursors. Let's just set this up. Wherever we are going into, I'll put a junction box over here, and it's going to be the same design for this one. All right. Keep it simple. Bend our 90 going into that junction box. Now here, same thing. Actually, pause for a second just to do a quick reminder. All right. Same thing when you're dealing with the 90. Now I'll make this one 3D in this case. You have 1, 2, 3 knockouts on the bottom of this conduit. You need to figure out which 3 you're going to use. Coming back over to this conduit over here. Same thing. I have 1, 2, 3 KOs on this side. I have to figure out which one I'm going to use. This is where I say measurements are the hardest part to get, because how good are you at doing this? The more experience you have, the better you get. One of the things I like to do is a short little piece of conduit, because I'm going to be putting a conduit in there anyways. And now I can put my level on this conduit, and same thing, I can put a piece of conduit coming out of this junction box, and then I can put a level over here. And now I found my 2 sides. All right, just a thing that you can do. The other thing you can do is use things that are in the area. What if there's a plumbing pipe right next to this? Okay, I can measure from here to here and then know what this line is going to be. So there's a lot of methods. I like the conduit method because for me, I always have the conduit. If there's nothing else around, big giant wall, well, what do I have? So the conduit method is usually the better one for me. So let's just pick 2 junction boxes out of here, right? Maybe these are taken up, and so I can't use those. So we're going to pick the one closest to the 90. Closest to the junction box, and we're going to keep it nice and, there we go. I do want to make them semi-nice. Kind of tight, and we're going to go into the top one over here. All right, so this becomes our 90. All right, it's important that we understand it in this dimensional form, even though it's only 2D here. Hard to draw a conduit in 3D. Because this changes our height. If this 90 came from the back of this one to the top, to the middle one, different height for the 90. From the center to the top, different height. From the center to the bottom, different height. So any other thing that we choose to do changes the 90. And more specifically, not just the 90, because the 90 will probably be the same height if you went from all 3 of these to the 90, to the top one, but it'll change your length, right? The important one from the 90, which is from the back of the 90 to the junction box. So these are the 2 measurements that we're going to need for the 90. We're going to need what they call the height. They don't call it a rise for the 90. The rise is used for the offset.
So we talked about the half-inch RMC?
Not yet. We'll get into that yet. Not yet. That's a very good, which is the thing that we do have to worry about with a 90 is the size of the conduit. Very good. So let me give these two sides. I usually like to change the color for stuff like that, just so we're not, understand what all the lines are between here and here. So let's give this two numbers. It doesn't matter what these numbers are. Let's go with 12 inches here, and let's go with 36 over here. Now, this is not an offset, so we're not worried about a degree. We know what the degree is. It's 90 degrees. So the other most important thing with a 90 now becomes the gain, not the take-up. The take-up is what you need to know how to make the 12-inch 90. Right? You have your straight piece of conduit. Where do I put that mark that I'm going to put on the bender? Well, I subtract from this number the take-up. For gain, because this conduit is going to actually gain length, because we don't make the 90 like this. We make the 90 with a radius here. So this area has to go this way or it has to go up. In other words, you're going to either get more conduit this way, but more than likely you're going to get it the other way because you're making the 90 the small end. You're not making the 90 at 36. You're making your 90 at 12. So now I have to take away what extra conduit I'm going to have. For all of this, we need to know what the gain is going to be, and so what we need is the conduit size. So we need to know what conduit size it's going to be. Let's go with 3/4 RMC, and you'll see the reason when we go look at it. It's because it's the whole number of all of these. These have fractions. We'll get to fractions after we just get through the easy part. After we get through the formula, which I try to use the easy number. So 3/4 RMC has a gain of 4 inches, meaning, because this 90 is not made like this, right? This 90 is made with a radius here. It actually pushes it. You can do this with a piece of paper too. You can take a piece of paper and fold it like this, and then take a piece of paper and put the 90. And you'll notice that one of your sides has more paper than the other one. All right, you can do these experiments. I mean, I don't have to show it, not a big deal, but you get it. Or just trust me that there's gain. So we got to take that away. So let's do the steps like we did the first time. And sorry to make this conduit number so large. Let me just make it smaller. We don't need all that. I use the room. So RMC, this is going to be a 4-inch gain, just to remind you of what it was. So let's do the steps. Step 1 is the same as we just had. Add up all sides. And by the way, this will be step 1 for all of them. This will be step 2 for all of them. Never forget, bring your +1. All right, so I'll just put it like that. Remember, it's for the threads. And now subtract, not add. Don't forget that, because if you add, it becomes a whole different number. We subtract the gain. So, now that we have the system down, I'll pause here and see how we did. What is my TCL? I know subtract is one word. It looks like I put it as 2 words. Subtract. And again, as last time, when you got that number, just let us know.
85?
I think we've gone too far.
Too far.
Yeah, because if you add 36 plus 12,
12 to the side. 48 plus 1.
yeah, so we're not going to be going more than, what does that become? 38 48. So we're not going to be going more than 48. We're actually going to be doing less than 48 because we subtract.
45.
45.
45 twice. Let me just make sure that everybody's got it. Mr. Roman. Now in this case we have two sides, right? Did you get 45, Roman?
No.
No. All right, let's walk through it. Let me move this little. There we go. So 36 plus 12, right? So add up all sides. That's the first thing we want to do, which is 48. 36 plus 12. So we got that. We got our plus 1. So far, shouldn't be too much of a complication. So 49 is where we're at right now. What's the gain? What do we have to do with the gain?
So 12 times 4?
No. Not right. So no, that's not. It's just we're just going to subtract that 4. 49 minus 4. 45. So we add 36 plus 12, gave us our 48. We added 1 for the threads, and then we simply just have to take away 4.
Oh, okay. Got it.
Very easy once you get it, and then from here, so straightforward. All right, good. So let's try it one more time, make sure we got it. Got it. And so things that will change, like, and this is as complicated as the questions can get, right? Because how much can it do? Let's go now, as always, do the second one with some fractions just to kind of make it a little harder. We will do ½ RMC that has a gain of 3.5 or 3.5. Sorry, excuse me, not 3.5, 3.25. Or if you want to use the parentheses, 3.25. Sorry, the decimals. I should say the number in the parentheses, it's 3.25. Now we just need our dimensional space. Our two measurements. So we will go with any numbers, doesn't matter. Let's stick to some fractions. Let's go with 10.5 here. Actually, yeah, 10.5 is fine. And let's make the distance between these 2 points another fraction. Let's go with 28 3/4. All right. And because you're looking at some fractions, my best approach here is everybody becomes a decimal. And then right at the end of this, before we go into the combinations, I'm going to explain bringing the decimals back to fractions. My way. Because I know you guys talk a little bit about it in Code A. I'm going to show you my way to do that, which is the best way. The only best, actually, that's on recording now. If any teachers are watching. Sometimes they do. I do. I watch all videos of the classes that I get asked to teach, so I know who's doing what.
I got almost 37.
Almost 37, I'll take that. We'll call it 37 for now.
Mm-hmm.
I think I heard that number being thrown around the classroom. Has anybody got a more specific number?
37.
37 as well? You're going 37? All right, good.
37.
Yeah, sounds fine.
I just do like not the 2, but then 2 30.
No, but the only reason I say, does anybody have another number? It's only because I'm wondering how we get close to 37.
I got 36.25.
36.25. I was wondering if there wasn't another number floating out there.
37.
All right. Okay, so let's walk this out. The only thing I just want to make sure is that we're not calling this 37 or something like that. So let's just walk through it. So add both sides. So 28, I'm going to go with 0.75. Again, easiest way to do that for me. Plus 10.5. There, I've added two fractions together. And I get 39.25, which is a quarter, so you can just bring that one back to a fraction, but I'm gonna call it 2/5. And now I'm making a connect here, so we'll see. Let's see if it continues. 1. So now I have 40.25.
I did it by 4 instead of 3.25.
Am I good so far? Yeah. By the way, if you see me do any bad math, tell me, because this is my 3rd class for today, so I might get a bad math here. Now I'm subtracting 3.25. Well, now I might be seeing that 37 show up. So 40.25 minus 3.25, and we have a winner, 37. Very good.
Even
Mr.
though I
Goldman.
have it written down as
But now you can see, sure, if we made a mistake here and there, all good. These things happen.
as a 4 instead of the 3.25, that's why.
Ah, got it. So you treat it as the 4 other than. Okay, so you know exactly where the mistake was. So, yeah. But the formula you got down, so we're good with that.
Yeah.
Excellent. All right, you guys doing great. All right, so you guys will be doing some of this tomorrow. All right, now you got the 2 major ones. Tomorrow we'll look at combination. We'll go offset with a 90. But let's wrap this up with, and let me now change the background. Don't need it. One last thing, because it's 8:21 now, and to get into a combination would just take us too long past the time. And I do want to explain this, because tomorrow you're going to be using some of these formulas to do some bends. I want to make that a little straighter, not so straight, but. And I don't want you guys lost when you grab your tape measure, because if you use my decimal format, when you can and don't have to, then fine. Like that other one, we didn't have to do those 0.25 for the 10 and a quarter. Right? I could have just understood a quarter and 375, that becomes 1. So that's easy. Sometimes it's not easy. So let me go through the fractions. So we know 3 fractions that should not be hard to find on the tape measure. Because that's the other thing to consider, is how good can I see these numbers on a tape measure as well. All right, so the quarter, the half, the 3/4, let me fix that quarter. Half and the 3/4, we also should know the decimals to it. If you don't, here they are, right? 0.5 and 0.75. So I already know what the quarters are. A quarter, a half, and a 3/4. These are the quarters, right? Starting with 0 going all the way to 1. These are my quarters. Here's a rule in conduit bending and in installation of components or equipment of any kind. We do not use ever 1/16 of an inch. No. Do not ever bring anything to a 1/16 of an inch. Ever. Don't ever make a mark on a 1/16 of an inch. If anything you measure is a 1/16 of an inch, move it over a 1/16 of an inch and make it an 1/8. And that's as far down as we go on the tape measure numbers, to an 1/8. Never to a 1/16 of an inch. All right, good so far?
Do we round that up or down?
Any
Like-
direction you want. It does not matter at that point. Up or down, does not matter. It's a 1/16 of an inch. You know what a 1/16 of an inch is? That is a 1/16 of an inch. Literally, that mark. It's so small that it doesn't matter if you went this way or if you went that way. The 1/16 of an inch is the thickness of a Sharpie pen. So when you're making your mark on a 1/16 of an inch, you're already bringing it to the 1/8 that's right next to it. So in the world of conduit bending, this is large component parts. Even a 1/2 inch is already big. A junction box that you're mounting, a panel that you're putting up, anything that you're mounting, do not mount anything to a 1/16 of an inch. Always to the nearest 1/8. So what this does when we're dealing with decimals is it simplifies things for us. Because no matter what the decimal is, doesn't matter what the decimal is, whether it's 0.16, whether it's 0.32, whether the decimal is 0.41, or whether the decimal is 8.82, I know what the number has to be because I'm not using a 1/16 of an inch scale. So 0.16, 0.17, 0.18, 0.1 anything becomes 1/8 of an inch. Or like we did when we had that number a few back that was 0.04. We just get rid of it because it lives somewhere right here. So we just make that whatever that number is before it. 0 in this case. All right, 0.32, I don't care what it is. It's 3/8. Maybe it's the 16th that goes here. What is that? 1, 3, 5. Maybe it's 5/16. I don't care. It's 3/8 of an inch on my tape measure that I'm marking. Same thing with 0.41. Same thing with 0.82. Now, can I make 0.82, 0.75? Sometimes. Sorry, 4.1 is actually in the wrong spot. I just realized that now. I meant to put 6.1. I don't know if anybody caught that, but 4.1 should be over here, right on the other side of 5. Now again, so can I make 0.82 3/4? Maybe. Can I? Can I move the junction box 1/8 of an inch? Probably. A panel for sure. In fact, I would even say a panel, it's either going on whole numbers or half at most. I should be able to move a panel 1/2 of an inch up or down. So those things will be relative as well, right? We don't have to get too far down the rabbit hole of when to do what. You guys get the point. Ignore 1/16 of an inch, bring everything to the nearest 1/8. And again, there'll be circumstances like if I'm working with 4-inch conduit, this is a very large conduit, I might be bringing everything to the nearest 1/4 just because 1/4 of an inch on a large conduit doesn't reflect that much of a difference. Same thing for the fronts. On a 4-inch piece of conduit that's going, across something, does 1/4 of an inch on each side now. So 1/8 and 1/8. Did I really affect anything by making it? Probably not. When you'll make those decisions, experience in time, I would say. But for now, we just start simple with right here. Understand this decimal situation. Bring it to the nearest fraction as you guys start to do the math tomorrow and the rest of this week. All right, it's 8:27. I'm going to pause the video right there.